हेलो कर दे हाँ हाँ okay, I think we have started.
So should I start?
Yeah, please go ahead.
Yeah. Okay. Good evening, friends. Today we have with us Dr. Gururaj HL, who is a distinguished speaker at ACM. Also, currently serves as an assistant professor in computer science and engineering at Vidyavardhaka College of Engineering, Mysore. So, to begin with today's talk on blockchain technology and its applications, before starting, I would like to tell you all that towards the end of the session, we'll have a Q&A session. So, you people can keep posting your questions in the comment section as and when you have them, and sir will answer them towards the end. So, you can now take over.
Thank you, Shruti. Thank you so much. Before starting with the presentation of my talk, let me share my screen. Please tell me whether it's visible or not.
Yes, sir, it's visible.
Okay. The thing is, what I'll do is, first of all, I would like to thank the chapter of ACM at NIT Surat for, inviting for me for this wonderful session. I'll go with the first half of the session. I'll go with the basic introduction towards blockchain. As we can have, as I inquired, we may have different audience type. So I'll give the brief introduction towards blockchain, and half of this session I'll go with the various applications what we built. Okay, the that is the agenda of my talk of this wonderful evening. Good evening, friends. Today we are in the era of communication, correct? I mean to say, we all depend upon internet, correct? The internet era has been started in, actually the origin of internet has been happened in 1969, okay, by AT&T, and that network they called it as ARPANET. Okay, so later it was used by that was changed by TCP/IP model in 1983, and it was developed by Robert Kahn and Winton. There was a couple scientists that developed this TCP/IP model. Okay, so this model is the one of the finest model across globe. Even today, for various communication activities, we are going to use that. Okay, so what I want to tell you at this point of time is, this is the generation of internet, but currently we have there is no structured architecture for any kind of network or any kind of domain. Okay, with concern to blockchain being a new domain is rapidly growing in adoption across the world. Okay, it might be in the form of crowdfunding and launch of cryptocurrencies. Okay, so if you would have saw the brief, just the if you would have heard of this name, Bitcoin here and there. Okay, so people will have many people in the world still think, even today also they'll think that blockchain is nothing but Bitcoin. Okay, such is the impact that Bitcoin has created on people and system across the world. Okay, so but that is not same. I'll in the meanwhile I'll give the brief introduction towards Bitcoin. I'll give the detailed conceptual view of blockchain and all. Okay, before moving to the introduction, I want to I want to tell you a very important standardized meaning of blockchain, which is a continuously growing list of records called blocks, which are linked and secured using cryptography. Very simple. Okay, if you would have taken the linked list as an example of data structure, each node where they are linked each other, correct, and each particular link has been depend upon the next link. Okay, so if you want to take the facet of cryptography, why we require the cryptography? To secure the data. Okay, and especially now especially nowadays we all depend upon data. Okay, if your friends or anybody ask you to give the give some currency, like it might be some 100 rupees, or it might be some sharing of the watches, clothes, whatever, you'll do it. But if anybody asks you to take over your phone or mobile device, or it might be a data, you'll feel nervous. I mean to say, you're not happy to give it. Okay, what I want to tell you at this point of time is data security or data plays a very important role nowadays. Okay, so how best we can secure the data, that will be the best suitable system for nowadays for networks, computer networks. Okay, so with this definition, and by honor these two important person having the most contribution towards blockchain, one is Haber and Scott. Now let me go for the myths of a blockchain. What exactly the blockchain? A blockchain consists of mainly three pieces of information. Okay, very important three pieces of information. One is data, one is previous hash value, and hash value. What is the meaning of previous hash value? I think data, you might have been heard of this name quite oftenly here and there in various subjects, or it might be day-to-day word. Okay, the intended, the message which you want to send from sender to receiver. Okay, it's called as data. Okay, previous hash value is before that I'll pitch into that hashing function, hashing mechanism, or the type of hashing technologies quite later. Before that, please remember this just in a superficial way. Previous hash value is nothing but the hash value computed by the previous node. The hash value is nothing but the hash value computed by the current node, present node. Okay, so these three information which are bombarded or packed together, and we can call it as a block. Okay, my dear friends, if you want to think in this way, a block consists of three pieces of information. One is data, one is previous hash value, and one is hash value. Okay, and I think even today also there is no proper person who developed the Bitcoin or whatever and all. We can call him as a Satoshi Nakamoto, and again, it's not a name of a person actually. Okay, so who designed this and all without knowledge of without having the knowledge of basic underlying concept of networking, or it might be any kind of networking architecture. He come up with a technology and he called it as a blockchain or Bitcoin sometimes, and we don't have proof of work for who developed this and all. Even today also it's called as pseudo person and pseudo currency will call. Okay, so what I want to tell you is the person who developed this, that person who developed this, the first block, he called it as Genesis block. Okay, I think you might have been thinking this way. You might have been heard in this way. Okay, blockchain obviously will have a credibility in our mind that it consists of lot of chains. Yes, exactly. Okay, it forms a chain using different blocks, several blocks, and the first block of that blockchain we have to call it as Genesis block. Okay, and that block obviously there will be a data to forward, but there will be no previous hash value. Why there will be no previous hash value? Because that is the first block of your blockchain. Okay, before that nothing was there. Correct, so the computed hash value for the corresponding data, okay, that is your hash value. You can see in the a picture which represents the second block. It's going to have previous hash value of the first block, and the third block having the previous hash value of the second block, and so on. Okay, so this is completely interconnected among themselves. They are completely interconnected. Okay, if one chain or some chain or block added without attacker and all, it will be not taken by anybody. Because for example, block number 3, let me take the example of block number 3 in this picture. Okay, this block is not only depend upon 2, it's also depend upon 4. Correct, no? So I mean to say they are totally interdependent. Okay, simply if I want to insert in between, I cannot able to do it. The block 2, for example, if I want to insert a new block in between 2 and 3, I cannot do it easily. Okay, the block 2 has to agree and block 3 has to agree. Correct. So these are the important things which you have to know. Just I'm taking going in the superficial way. I want to touch the all set of our audience. And blockchain mainly have five important features. One is called as hash cryptography, immutable ledger, distributed peer-to-peer network, mining, and consensus protocol. Okay, let me go over the detailed concepts of each and every one by one. Okay, and hashing. Okay, if hashing is a technique in which it will take a variable size of data, but providing it will generate the output of fixed length data. Any kind of hashing technique for that matter. It might be of SHA-256 or HMSC, one more hashing mechanism, any kind of hashing algorithms, it might be, no matter. All the hashing algorithms will take the input of variable length. Okay, it might be of 100 bytes, 200 bytes, whatever. But when it's generating the output, it will be of fixed length output. Okay, out of such hashing category of algorithms, we have one of the standardized algorithm called SHA-256 algorithm. Okay, SHA stands for Secure Hash Authentication 256 algorithm. So why we have to use the same algorithm? It's not constant. Okay, any hashing algorithm out of those, when they some results says that this is one of the finest algorithm which we can incorporate for blockchain. Okay, so they in which we can provide better security compared to other algorithm. Okay, so compared to existing other algorithms, SHA-256 provides better security, and the output of this is 64 characters. Okay, 64 characters, hence somewhat it provide the better output. Okay, so hence the blockchain, for that matter, this algorithm will be used. Some features of hashing, let me see. Okay, the output of hashing algorithm will be not at all same as others. Same, for example, it will be completely unique in that matter with respect to each and every individual. For example, for that matter, I had taken here a conceptual view of it. As each and every individual, there will be unique fingerprints, and similarly, the matter of data might be of anything. It might be text, it might be audio, video, PDF file, text, whatever it might be. It is going to generate 64 characters data. Okay, that is the that hexadecimal characters it is going to generate. Okay, and each and every data, it's going to have different output. Okay, so what are the fundamental features of this hashing algorithm? Why it is very important, especially in blockchain? Okay, and still I had not given the complete flavor of blockchain, my dear friends. I can understand. I'll give you the flavor of all these features, then you'll able to understand why this is much important. Okay, the five important properties the hashing algorithm follows are: one is one-way function, one is deterministic, one is fast computation, avalanche effect, and it will withstand collision. What is the meaning of one-way function? I have a text file, I can generate some input data, I can generate the hash value, but keeping that hash value, we could not able to generate the original data. Okay, that is called as one-way function. Okay, what is the meaning of deterministic? Deterministic is nothing but it is going to generate a finite and unique 64 characters, which will be not same. Okay, and it will not take much time, very complex time, or it's going to have much complex time to evolve with the computation. No, it's not like that. It is very simple. Okay, and if some small change in the input data happens, that will affect the drastic output in the 64 characters. Okay, so that effect is called as avalanche effect. A small change in the input, or it might be in the series of the communication, that will affect the output drastically. Okay, and it also withstand collision. An example: at the same time, for example, we'll consider a time as 5 o'clock. Exactly at that time, two person they want to send the same data. What will be the collision? Obviously there will be a collision. Okay, both will generate the same hash value. Okay, in that situation, it is going to consider the prioritized data, and also the time slice it's going to consider. Okay, using time slice along with the data, it will combine each other and it will produce the hash value. Okay, so these are the five important characteristics what we can have in case of hashing algorithm. Okay, so right now I have given a brief introduction towards the blockchain I had not given much introduction towards the history of it. Okay, right now. Okay, basically there are two types of networks. One is centralized network and one is decentralized network. What is centralized network? Centralized network is nothing but client server. You can take the example of any shopping websites, like it might be Flipkart, Amazon, Snapdeal, or it might be social networking websites like Facebook, or it might be mailing websites like Gmail. All they follow the fundamental architecture of centralized architecture. Okay, what I mean of centralized architecture, there will be a centralized server. Whatever the request you're going to bombard, all the requests will be processed by the server and it will reply back. If you want to do any kind of communication, all the communication will be monitored and happen with the help of server. But in case of peer-to-peer, it's not like that. Okay, what is a major drawback of client server? If the centralized server fails to work, the complete network fails. Correct? Complete network fails. Okay, so that is a major drawback for client server architecture. But in case of decentralized, it's not like that. If any node fails to work, that will never affect the complete network. Okay, if that node fails to work, if he is going out of the network, no matters, all other nodes will work appropriately. Okay, so but even today, each and every business enterprise, or it might be communication, they'll follow client server. The only reason is that they don't want to give the complete proprietorship of that particular server to somebody else. So that is the reason they don't want to distribute their ownership to everyone. Okay, so that is the reason why even today also people are following many companies or enterprises, they're following client server architecture. Okay, when it comes to the point of blockchain, it is a decentralized architecture. Okay, no matter how many nodes or what is the kind of network it might be, there will be no centralized server at all. Every node, they behave like an individual computer or individual node in the network. Okay, they will process, they will operate themselves, and they'll perform the operation. We have a lot of technologies even today, all follows the centralized architecture with lot of drawbacks. Okay, so quickly I'll go with some basics with the help of an example like this. Okay. Okay, as I said, you people that this an example where we can think in this way, for underlining people those who are not at all aware of this blockchain. Let me consider any number of blocks. Let me consider the first block. Let me go with the hash value. Okay, the importance of the hash value. If I type something like NIT, National Institute of Technology, got some hash value. If I type SURAT, completely changed. You can see the changes. This is an online or open source application website that is built with the help of blockchain basics. So you can roughly understand the blockchain with the help of these examples. Okay, whatever the type of data you're going to enter, it is going to generate a unique 64 characters hash value or hash code. Okay, so that is one thing, and the uniqueness you can see here. Let me consider a block. Block, as I said, it consists of mainly three important entities: data, hash value, previous hash value. Okay, let me consider this as a block one. Okay, what is nonce? I'll tell you that later. Okay, let me have some data, and it's going to generate the hash value. Let me have something like ACM. I have the hash value, and once that hash value, what is going to generate, for that corresponding nonce value will be there. Okay, corresponding nonce, please remember this, corresponding nonce. Okay, nonce, what is the meaning of nonce? Then once a random number that should be used only once in the operation, hence it is called as nonce. Okay, let me mine. I'll talk you about mining operation later. No need to worry about that right now. Okay, let me mine this. For that corresponding value 9057 nonce, it's going to mine. Okay, it's an example. It's an example. Okay, and what you got from this, for the corresponding nonce value, we got that mined. It's changed the color. Once it converted to green color, its meaning is it's mined data, mined block. Okay, And let me understand. Let me tell you more on this for the better understanding. And nonce is a one that will be generated randomly, such a way that that nonce value, if I would have used to crack some cryptographic, puzzles, it will crack it out. Okay, I'll tell you all those things later while explaining the detailed concept of mining. Okay, and this is one thing. And how the blockchain works, I have let me have three important blocks, and let me type some hash value or something like high. Immediately change. Okay, all the blocks are not mine now. I want to mine. Okay, let me call the first block as 1 with nonce value or something and have entered the data. As we call the first block as genesis block, we don't have any previous hash value. We have the hash value for the data high. Okay, let me mine. For corresponding value 13631, the data block has been mined. Let me go with the second block. Let me type NIT. Okay, and hash value will be something like this. The previous hash value will be the first block hash value. Okay, so for the corresponding nonce, it will again mine. Let me go with the operation 44556. Okay, let me go with third block. Let me enter it the data as something like this, Surat. Okay, if I enter the data, if I try to mine it, it will again for a particular nonce value, it's also mined. Okay, we have a blockchain, a small blockchain with 3 blocks. An example. Okay, if I would have changed some block, second block, see here, completely the rest of the connected chains has been blocked down. What I want to tell you at this point of time is the hash value of the second block and third block are totally related. Okay, let me correct it. Immediately it will also correct. Okay, so if you would have changed something here, it will not affect the first and second block. Understood? So what you got from this, if you would have changed something in the first block, okay, that will affect completely the chain itself. They are totally related. For your better understanding, I took this website, and I'll go back to your things. And the second until so for what we discuss is blockchain is a decentralized network. It's a geek word nowadays. It's roamed like anything across the globe, and this blockchain mainly consists of 3 pieces of information and with some features. Right now I had explained the cryptographic hash value and immutable ledger. Immutability is a property wherein which once the data has been entered, that should not be changed at any point of time. Okay, that is the beauty of immutability. Okay, so let me check out how this immutable ledger helps us to perform the operation with respect to blockchain. Land deed records. I think you might have been heard of this name called as land deed records. If I want to write a will to somebody, or if I want to change the ownership of some assets to somebody, that operation is called as land deed records. Okay. The traditional ledger, I think you might have been go through with this. Like if you want to enter some laboratories and all, you have to write your names. Or if you want to go for some banking transaction or some libraries and all, you have to enter the details. All the details, when you logged in, when you logged out and all. It's a ledger. If small change has been happened, that will completely affect the ledger, correct? No. So similarly, if the small change has been happened in the blockchain, it will completely affect the complete blockchain. Hence it is called as immutable ledger. Once the data has been changed, it should not affect. Like, we'll see here, some block has been entered, nice chain blockchain. Some attacker has been inserted a new block. What it happens, it will affect completely. The rest of the blocks will be completely affected. Okay, why? Because they are totally depend upon this block. Understand? This is what exactly the meaning of immutable ledger. Okay, so the next very important feature of blockchain is distributed peer-to-peer network. As I said you people that it is a decentralized network. In other terms, we can also call it as distributed peer-to-peer network. What's the meaning of distributed peer network? Okay, we don't have any centralized network. We have a network like this. Let me have, for example, 6 nodes in the network. Each and every node in the network of this size of 6 nodes, they can communicate among themselves whenever they want, whatever they want. Okay, we don't have any kind of centralized network or node there in which if they want to communicate with the other node, they have to contact the server. No, it's not like that. Okay. That is one of the very important advantage of blockchain. I can call the feature as transparency. Or what exactly the meaning of transparency? I have 6 nodes in a network. I want to, for example, the node number 1 he want to transact, for example, 500 rupees to node number 2. Okay, that transaction should be replicated to each and every node in the network, saying that node number 1 has transacted to 500 rupees to node number 2, to all the nodes in the network. Okay, you might have been think in a very fascinating way why that is required for all the nodes. Okay, at this point of time we feel that we are not at all we bother for that, but whenever it comes to the point of security, whenever it comes to point of it matters a lot. Okay, so that kind of transparency we can have in this particular distributed peer-to-peer network. And if any new node, if any one new transaction happened with respect to node number 1, and you might have been heard of why this 1 2 3 4 5 6 7 8 small blue color ball blocks we have, that means that this network have but 8 transaction. All 8 transaction is replicated at everyone. Okay, each and everyone knows there's a transaction happened between these two parties. That is the meaning of transparency. If any block added, simply if any transaction happening, that transaction will be not simply obeyed by everyone. Okay, so what it happens, that will be sent to each and every node in the network. Okay, they all accept that data, and then we can have that particular transaction in the network. In the meanwhile, an attacker inserted an attacker node between the network. What happens? Okay, the direct connected nodes of that particular block will be intermitted. You can check out here for 3 nodes. What about the rest of the nodes and other maximum nodes? They feel that the block is right, which is in the green color. Okay, what they'll consider the maximum values. We have only with what this will indicate these 3 guys, but all the rest of the guys, and they have a lot of other majority value, and hence they'll consider the transaction for the respective network. Okay, so this is the brief understanding of blockchain, how distributed network works, how the very important property called as distributed hashing cryptography works corresponding to blockchain. Okay, now we'll go with one more important, very important property of blockchain called as mining. Okay, how mining works, what exactly the meaning of mining? First of all, data mining, I think you might have been heard many of the times, but mining with respect to blockchain, what exactly the meaning of that? Okay, if there is a situation where a new block, he want to block resides on a machine. I think I'm a person, I want to enter the network. Okay, I have to enter along with my machine or device, correct? No, so if I want to enter the network, each and everyone has to get compromise saying that yes, we can able to accept that network to my small group. Okay, so how that works or performs, basically with the help of mining operation. What exactly is the meaning of mining? Mining is a mechanism where it will select that block based on the target value decided by the miners. All blocks in the network. Okay, an example, you can see an example. Okay, I have a nonce value without some value. I want to insert this block weight to the network. An example, that's a scenario. I want to insert this block weight to the network. Okay, so what I'll do, what are transaction he want to do it? He want to have a transaction with some data and previous value and hash value here. Okay, so he is going to have a nonce value of 20 with this hash value. He is going to have a nonce value of 21 with this value, and now they have decided the possible hash values I can take up for this particular blockchain network. They used to consider the minimum hash value. Okay, you can check out in this picture. We can we have represented here 16 zeros and 16 some characters in the third line, and 8 zeros, and rest of the things are in characters. And the first line we have it all characters. Out of this, which is the minimum hash value, obviously the last one, correct? No, so the nonce value, when it's going to crack the puzzle, what is the puzzle? It's nothing but cryptographic mathematical equations or values they are going to post to the miner, blocks. Okay, those who wanted to insert their block into the network, we can call them as miners also. Okay, they have to keep on solving the cryptographic methods using the nonce value. At some point of time, the nonce value cracked with the hash value that will obey with this target value. You can check out here. Okay, this is a small, always it will be the smallest value. Okay, so whenever, for example, okay, so for the nonce value 143, the cryptographic hash value will be something like this. Okay, for the nonce value 5012, the cryptographic hash value will be this one. Okay, I mean to say that the minimum cryptographic hash value got with the help of a nonce value 5012. I mean to say the miner cracked the cryptographic puzzle and he can able to insert to the network. Okay, so this is what exactly the meaning of mining, and this is where exactly Bitcoin and all plays a role. Bitcoin, actually, I'll give some inputs towards Bitcoin right now. Bitcoin is nothing but pseudo currency. Bitcoin is nothing but pseudo currency. It's we don't have any kind of bitcoins. I think Indian government. I think we all know about the how exactly India. All politicians and all how they works and all. We all know it. Okay, so bitcoins especially is not run. Especially in India, it's not valid. And bitcoins are not the actual currencies; they are the pseudo currencies. After some collection of pseudo currencies, they can able to convert to real currency in other nation, not in India. And now, whenever they want to mine the value, they will be assigned with some bitcoins. Okay, yes, you won. Congratulations, this bitcoins has been assigned. That's what happens. Okay, so if you are very happy to work on Ethereum tools, Ethereum is one of the two. I'll speak a few words on Ethereum and other things later. Okay, so the next important feature what we can think of regarding mining is Byzantine fault tolerance algorithm. Okay, method or methodology. Byzantine fault tolerance, it's not a new mechanism. It's again very oldest method. They have adopted this method to blockchain. That's all. Okay, let me assume there is whether to consider the block. I can imagine in this way whether we can consider that block to the network or not, or whether consider that particular entity to my network or not with the help of this mechanism. It is a problem statement. Okay, we have four nodes here, four emperors here. They have to attack the fort which is present in the middle. Obviously, there will be a leader node. We'll call the node number 1, the first node, as leader, who's going to have a crown in his hand or something like that. Okay, he will send a message. Either he has to send a message saying that he will attack the fort, or else he has to send a message saying that not to attack the fort. Okay, so what he'll do, he will send a positive message to each and everyone. Will attack the fort. Will attack the fort to everyone. He will bombard the request to everyone, and ultimately they'll attack the fort. Common scenario. There will be an attacker. The node number 2 is an attacker. Okay, what he will say? He will receive a message from the leader saying that will attack. The green arrowhead you can see directly for first arrowhead, second arrowhead, and the third arrowhead we can able to see here for all the nodes. But the node number 2 will send back a wrong message to node number 3 and node number 4. You can see the red color arrowheads saying that not to attack. But even though he will send a wrong message, the node number 3, let me consider how many attacks he'll get. He got a majority of 2 attacks and 1 not to attack. So he'll again obey to attack. In the similar fashion, node number 4 also receives only 1 message for not to attack and other rest of the 2 messages to attack, and he'll also agree to attack. Okay, this is one of the example. Sometimes the leader itself is an attacker. Many of the times we can have a situation where the leader itself is an attacker. He himself is an attacker. What will be the scenario? Okay, whenever the leader itself is an attacker, he will send, even though he send a message saying that to attack the fort for 2 nodes and 1 message to the third node, last node not to attack. Again, they'll take the majority of the messages what they got and will perform the operation. This is what exactly the Byzantine fault tolerance, with a typical example to understand better knowledge on this. And same thing we can apply for your blockchain network, wherein which whenever the node want to enter, so immediately we won't add that node to the network. They has to crack with the help of cryptographic values, and after cracking the nonce value, he will be, or that node will be accepted by or convinced by all other blocks in the network. Then only we can able to add him to the network. Okay. So the last important part of this, the features of blockchain is consensus protocol. Consensus is nothing but compromisation. Okay. How the protocol, I mean, how the blocks will get compromised. Okay. Let me have a challenge here. What is the challenge? The first transaction, I mean, the last transaction, the first block is wrong. That will be sent. At the same time, there is a other transaction that's also a wrong transaction or competing transaction. How they'll go with? They'll go with two things. One with the help of proof of work or proof of stake. Proof of work is the operation or requirement of a miner, wherein which he has to. You can assume here. You can assume here in case of this typical example. What we're taken. What we're taken is the node number 1, the first node, and node number. You can check out the node. Let me consider the Valender color node as node number 6 node. They do both want to insert the transaction. They want to do the transaction at the same time. Okay, it is a situation where we have to go with two important operation of consensus protocol. One is proof of work and one is proof of stake. What exactly the meaning of proof of work? If I want to add each block to the chain, miners must complete to solve a difficult puzzle using their computer resources and power. Okay, and the other feature of proof of work is if in order to add a malicious block, if it is there, okay, you would have a computer more powerful than 51, I mean to say half of the percent of the network. If you want to add, for example, using the proof of work only, the miner want to insert a malicious node to the block. What the computer resources should be? He should have at least 50% of higher computation compared to the network. Why? Because that transaction will be happen to known to each and every one in the network. All the computation has to be happened by that particular computer resource. Okay, and the first miner to solve the puzzle is given the reward of their work, and that is what exactly called as proof of work. And if you have taken what is proof of stake, proof of stake is nothing but there is no competition, as a block creator is chosen by an algorithm based on the user stake. Okay, based on the user stake, the competition will be there. If the for the block creator, and he will be chosen as an algorithm based on the respective user's stake. In order to add a malicious block, same thing. In case of proof of stake also, it should have at least 50% of all the cryptocurrency in the network. Okay, so he should have that capacity, and there's no reward for making a block, so the block creator takes the transaction fee. We all know it. The who is going to create a block, that block will they'll take that amount as a transaction fees. Okay, there's a major difference between proof of work and proof of stake, and if any transaction has to be done, this has to obey these two important properties. Okay, and as I said, this is a repetition of the previous thing. If you have a wrong block added, a wrong transaction added, and it is transmitted, and at the same time the last block also send the data, it will take a majority. So it will leave out the last node, and that node is called as, that transaction is called as orphan block. Okay, that block is called as orphan block. Okay, so this is what a brief introduction towards blockchain and cryptocurrency and all. For executing, or if you want to build your own blockchains, or it might be on your own network, please try to build on test network first of all. Okay, and using some tools. Okay, we used a tool of Ethereum to create the smart contracts and all. If time, I think that's a separate session. It's just a insight towards the blockchain and its application. Let me give you a few applications what were built. Okay, we built a few application based on the tools properties. The first thing what I want to project for you people is where we have to apply this blockchain. Blockchain can be applicable, or we can apply this technique wherever there is a replacement of centralized mechanism. There will be a lot of centralized mechanism in the whole globe for various applications. wherever the chances of eradicating centralized mechanism with the help of decentralized mechanism, we can apply blockchain technology. One such mechanism, and again, whatever the applications, what I'm going to depict in front of you people, all the published in reputed journals, and all these applications are tested on test network, not a real network. I think we all know it, why we can't able to do it. Whenever the respective authorized people agrees to build on the real network, we can able to do it. We tried it for different application, and people didn't agree, and hence we built on test network. And with the help of a tool, the requirement specification for this is we had used Ethereum tool, and using a language called Solidity language. A Solidity language is similar kind of Java syntaxes they used to follow, JavaScript. And the first important application, and for the front end and all, we had used a few applications. We had used React JS to look nicely and all. I think that you can manage. Okay, one of these requirement where we can use blockchain is e-voting mechanism. What exactly the e-voting mechanism? There's a chances of, I think we all know, even today also, in India, we used to follow the mechanism of centralized operation in case of voting. Okay, if you want to cast a vote, you have to go for respect to booth, and you have to, it's like a local server, and that entirely they'll connect to the global server. Correct? No, so it's a client server. Okay, so why can't we have a voting mechanism with the help of a blockchain and all? And we thought in that way. Why it is? Because it is a centralized mechanism, and as I said, Bitcoin, for each and every transaction, when it is going to trigger the transaction, that transaction will be triggered with the help of a hash value, and for every transaction, some ether value will be as a transaction fee we have to give. Okay, for the application purpose, we're built in this way. And whenever you want to cast out a unique hash value will be generated, and that hash value will be used to cast the vote. And once you cast, it will be the Ethereum ether value will be used. Okay, so this is one thing. And one more typical application, as we examined with the help of a team of my research community, pet shop application, and adoption of pet shop also plays my major role. In case of Western countries, they'll adopt, they'll leave whenever they want, to keep track of all the transactions, what happens with respect to adoption of pet animals. We went with this application, and again, the same logic we had used for that also. And one more important application that is really needed the usage of blockchain is crowdfunding. Okay, and we don't know for very meticulous applications, very meticulous reasons, we people we are very much bothered to help the needy people, but we are not sure whether it is whether it is used properly or not. But in case you would have used this kind of blockchain application, there will be a chance of knowing the transparency by at last. Okay, whenever you deposit the money, and at last whether the amount has been used properly or not, the complete thing we can able to have in case of this blockchain technology. Okay, and one more application, I think IPFS, yes, interplanetary file system, we have built with this, and this also built to upload a few photos or a few files and all. Similar kind of this BitTorrent kind of application, a peer-to-peer application. That file is not only downloadable by the centralized server. If you have new files, you can upload the better one compared to the other one and all. Okay, this also have a look of kind of advantages compared to the existing mechanism, wherein which in existing mechanism we are going to have the look of centralized server. We have to download the files and all. But in case of this, we can upload any kind of files at their own. I mean to say at the end user. Okay. So these are the few examples, four important and along with this, we had built one more called as recently MetChain application. MetChain application is a scenario where in which for example, a patient, if he goes to some hospital for some diagnosis, and he has to underwent with many examination, like it might be urine test, blood test, sugar test, and all. And ultimately, the people will tell, if they could not able to do it, they'll tell that they refer to some other hospital. Okay, when the patient go for the new hospital, also he has to go with underpass with again the similar kind of tests. It's a tedious and cumbersome. Okay, so why can't we have a build of methodology wherein which I'll call it as medicine application, and we build that application, and we try to talk to the respective, authorized people. We could not able to build on the actual networks. We built on just the test network. Whenever the test patient is going to underwent, and he can able to record all the information on his own, with the help of his own privacy. Whenever the doctor want to retract the test, he can able to use his key and doctor key. He can able to view the test which is there in his local server. Okay, so by which we can able to reduce, cut down the capital invested by the patient also, which is of no use. And that is also one of the important applications where we can have blockchain as an advantage. And the last point which I want to project in front of you people is, I'll go with one more thing called if you really wanted to if you have any doubts at any point of time, you can contact me. I'm very happy to help you people. And yes, we have the community which is have an at our institution, and that also runs with the help of ACM student chapter, called as VVC ACM student chapter. And we have this faculties along with the external mentors, and we work on these platforms on, to build the blockchain applications. And few applications we built on IPFS also, and all. And if you really want to join, please join us. And we kind of apply. If you want to see the demo of those, pet shop, as I explained, e-voting and other things, it has to be updated, and you can see the demo of such application also. If you want to read the papers on those applications which we built also, I'm surely and very happy to exchange the papers with the coordinator of this workshop. I mean to say the talk. And this is what I wanted to say you people. And one more thing which I want to highlight, which is very very important, is blockchain. Those who are really interested, the people, much work it's going on by very two important organizations. One is CDAC Hyderabad, is the only organization. They are working on this particular, blockchain technology, and especially they are building on. They used to have a kind of opportunity for students also to build a blockchain, and they are converting all the land record properties of the complete Telangana to completely to this one. What is that? Blockchain. Okay, whatever we have right now, all land records, all the things, this acre of land by this person, kind of thing and all they are planning to convert the complete land ledger records to blockchain, there in which whomever they want to insert or whatever they want to insert, everything will be in the transparent fashion. Okay, so that is one more thing which I want to highlight. And one more thing is, across India, one more important organization, I think you might have been heard of this, I don't know, the people of IIT Kanpur, okay, where I had delivered a talk there also, and I visited this lab also. They're also working on national blockchain project with same thing, same kind of Ethereum, Hyperledger Fabric, blockchain DB and all. So they're also trying to build various blockchain applications at their end. Okay, this important application, these are two important organizations. Mainly they're working on blockchain, at especially at the government organization. They're working on this blockchain rigorously to convert the complete operation of the in India, whatever the centralized operation they have, they wanted to convert to the kind of blockchain application. Okay, and at last I want to convey a few things. If you really wanted to join that, you can able to join us with the help of the blockchain. And many applications like the trade-off application we can able to build, and we can have permission blockchain and non-permission blockchain, permissionless blockchain we can call it as. We can able to build such applications on the blockchain, and we can also build trade-off, various kind of trade-off application. For example, it might be you can think of trade-off markets like Sensex market and all. There also people are rigorously working to build blockchain. It might be a notary application. The notary application also there also we can build blockchain, and various financial transaction. wherever they want. They can also you can also build the applications on blockchain. And these are a few applications which I want to project in front of few people, where we can able to build the blockchain applications. Okay, that's all from my side. I'll take up a few questions for 15-20 minutes, and I can leave.
Yes, sir. Thank you so much. Uh, so, first of all those who are attending the YouTube live right now, whatever doubts you have, you can post in the comment section right now. And we'll start with the first question. So, Sir Prabhu asks that I find the current physical currency obsolete. I imagine a future where people transact digitally everywhere. How can blockchain help to digitalize this sector?
A very good question. Very good question. And what I want to tell you for this is, yes, the hard currency is completely obsolete nowadays. Correct? So, but converting. See, one more thing I want to highlight here. There are two important drawbacks of blockchain. Okay, two important. I won't call it as a pitfalls or drawbacks. I'll call them as challenging issues. And few people like you, people researchers, you can able to solve them also. The two important pitfalls or challenging issues are: one is scalability, and one is adaptability. The scalability is a thing. I think you might have been heard of this name, scalability, right? For example, if I want to do one transaction, I require, for example, zero point 0.1 ether value. Why? Because I want to send that transaction to everyone in the network. For example, I have 5 blocks, 5 nodes in the network. I want to send the transaction to all 4 nodes in the network. Okay, I'll require some, for example, for 5 seconds or 5 minutes of time. If I want to do the same computation on 10,000 nodes in the network, I have scalar. I have like anything, 10,000 nodes in the network. I have to send the transaction to 9,999 nodes on my network. Think of the computation efficiency, how much it requires. Okay, if it is as I said, we have kind of blockchains like permissionless blockchain, permission blockchain, public blockchain, private blockchain, and all. If I want to work on public blockchain, the transaction required to happen for each and every transaction for each and every node on the network, it is very huge. Okay, now you think of converting the blockchain for currency kind of thing. Yeah, exactly, we can able to do it. I can elaborate this the answer in this way. Two, initially we took for that, especially for voting application and crowdfund application initially, and merchant application especially. Initially we took only 10 nodes, 15 nodes and all. We used to compute the operation with the help of 1 or 2 machines, and we got the nice results and all. When we take for a test examination and validation, some suggested to go with higher number of nodes. We could not able to run the transaction in the machine, which consists of terabyte of memory and very high hard disk. Okay, and we require GPUs. Okay, we require GPUs just for, I think we took only 100 of 150 or 200 nodes. That's all. Think a situation wherein which if you have a transaction of lot of nodes in the network, it's not so scalability hinders the blockchain. Okay, so yes, we can able to go with the for soft currency, we can that kind of transaction, whatever we do with the help of a lot of gateways like phone pay, Google Pay and all, they also yes, we can able to incorporate, but this is one of the issue what we have. I think I had answered your question.
Yes, sir. Thank you so much. So the next question is Krunal says that, hello, I actually asked this question to someone who works at a bank, and I'll ask the same to you. Can blockchain threaten the existence of banks? That person replied against the statement. What are your views on it?
Bank statement, yes. Actually, I used to give I wanted to tell you this. I usually tries to give the example on blockchain with respect to banking application. Okay. Corresponding to banking application, the transaction, I think about adaptable. I think the second issue, this is the answer for the second issue of the blockchain. Adaptability is nothing but the change. It's a layman vocabulary. The changeover. Okay, it's not so easy. Before it was, they used to follow the cutout, or it might be cut payment, or it might be the rest out the transaction, whatever. They used to write everything in the ledger. Okay, when everything has been transferred to database with the help of computers and all, the adaptability was not so easy. Okay, and we should not only think of the banks of the urban banks. We have to think of the banks which are located remotely in the villages also. Okay, small gramina bank or something like that. Okay, so whenever the transaction happens, even today also, people will write the everything with the help of pen, with the help of bank statements, everything and all. Think of converting the complete blockchain concept to the banking sectors. It's not at all so feasible. Converting the company, why? Because we all know it, each and every person across India, the transactions are related. If you want to convert the complete thing to blockchain, so what they can do is they can set up the different types of blockchains with the help of public network, private network and all, and they can able to have their the customers of that particular bank on that kind of thing. I think they can able to do it. But for feasibility, corresponding to feasibility, we have to think of think also. When it comes to a point of transaction, I used to give the same example. The transactions and all, they are really transparent, and somewhat security also. I think no matter the security is really good, but when it comes to the point of feasibility, when you see the remote banks, it matters a lot.
Okay, sir. Thank you. The next question, Dhruv Rana asks that if someone wants to start and is new at blockchain, what resources would you suggest to start with?
Okay. If anybody want to start a new blockchain, obviously, I suggest you people please go with test network when you are initially start with any kind of blockchain or any kind of operation. Initially go with a test network which is readily available on the internet, like Ethereum. If you want to purchase such Ethereum tools, Ethereum network and all, it costs more. If you have the resources availability in the college, or it might be at the universities and all, you can use a test network and you can incorporate blockchain on that network. And if your test network works fine enough, whatever the application you depend upon, it might be a financial application, or it might be the transaction of the whatever the transactions and all, depend upon that application. You thought of asking the respective organizations, like it might be as we as the DHO, district health officer, to incorporate blockchain in the city, and immediately they say no for that. No, we'll go for the traditional network and all. So they have to talk to the respective organization, and they can incorporate. Initially, they require minimum knowledge of blockchain computer networks, basically, followed by blockchain, followed by some cryptographic methods, networks and all, cryptographic hashing techniques, cryptographic encryption and decryption techniques and all. And minimum resources, I can tell you, if we have some 5 machines, a small lab and all, they are very fine enough to work on blockchain initially.
Okay, sir, that makes it clear. Yashvardhan asks that, sir, can you please tell us something about Bitcoin Cash as well? And is it different from Bitcoin?
Bitcoin Cash, see, I think I'll tell you in this way. Bitcoin Cash, see, yeah, the question, really good question. Okay, see, what I can tell you for this is, I think for Ethereum they called it as Ether. For Ethereum, I'll tell you. Yeah, I can tell you in this way. I think it might be more accurate for the question. Okay, uh, for each and every nation, we have different currencies. Correct? No, each and every nation we can have different currencies. Similarly, for Bitcoin Cash, as they said, even today, I think what is a one Bitcoin Cash equals? The meaning of the value of Bitcoin one is equal to 18,285. I'm talking about only one Bitcoin, 18,285 Indian rupees. Okay. So each and every nation, they have different currencies and all, and they will be having conversion ratio and all, and it's also depend upon, since I mean to say, the financial status of the nation also. Okay, if the financial status, if we all know that $1 is equal to almost 80 rupees currency of Indian, That also depends upon this Bitcoin, Bitcash, and Indian currency also. What I want to tell is Bitcoin Cash is nothing but Bitcoin itself. And if you want to convert to the Bitcoin, actual currency, people will call it as Bitcoin Cash. That's all. Okay, that's what. After collecting some 100 bitcoins, 10 bitcoins, 20 bitcoins, and before Bitcoin, there will be small, Bitcoin again divided into small units like paise kind of thing and all. So once they collect the bitcoins and all, they can convert to the real cash, and that is called as Bitcoin Cash. That's all.
Okay, sir. The next question is from Mihir. He asks
Mhm.
that a lot to computation power and electricity is used for mining. What are your
Mhm.
views on this issue?
Yes. I think you have to work on smart grids then. Okay. I don't know whether you people have heard of this name smart grids and all, where the computation capability will be very high, very high. What I can tell is, obviously, if you want to have one thing, you have to lose other thing. If you want to have more security, if you want to have more transparency in the network, obviously that's what I say. Computation efficiency is very high in case of this kind of Bitcoin, where blockchain. Okay, so obviously it will use lot of resources, a lot of energy, a lot of just to mine. It will use lot of energy to mine the data. I think we have to do something on CPU operation. I think I'm not into the systems. I'm into this kind of practice research. So I don't know much on that kind of system research.
Okay, fine. Mihir also asks that is gas fees limiting the usage of blockchain? As to
No,
write
no.
data on blockchain, also we have to pay some amount of gas fee.
Yeah, no, wrong. What? It's not like that. Gas fees, same thing. I think is somewhat good at Ethereum tools, I guess. See, the fees, what you have to use, it's very limited. It's very limited actually. Okay, and you have to use gas fees just to take some. No, if you want to work on that blockchain, okay, it's very limited. It's not expensive and all. I think you guys, when you're into IITs and NITs or some premier institutions like us and all, the college and they'll sponsor the labs and all those kind of resources. Okay, so you can go with the gas fees and all. It's valid.
Okay, thank you, sir. Sahil Bondre asks that how does the computation cost of a blockchain network compare with current cloud based centralized solutions like AWS? What do you
Mhm.
think will make enterprises embrace blockchain as they did for cloud?
Yeah, fantastic question. See, I think we all know it. Even today, also the best cloud across globe is Amazon. Okay, it will use EC Square. I think Elastic Cloud Computing. Okay, so even that cloud, when you talk about cloud, it's a centralized one. I think if you want to know more about Elastic Cloud Computing, please Google it out. You'll get lot of videos and all. The finest cloud across globe. What I want to tell you at this point of time is, to construct such cloud, they took almost many years to come up with such architecture of the cloud of Amazon. I'm talking about only Amazon. Even today, people will thought of like Google is the biggest cloud and strongest cloud. No, Amazon having a nice architecture on cloud. So the energy and see, the major drawback of client server or centralized architecture is, even today also we never heard of that server fails, this server fails, or it might be the data has been leaked out, or data skill injection attack happens. No, we never heard of that. That is a maintainability they used to have in case of such clouds. So, and when it comes to the point of blockchain to such cloud computing, yes, and few researchers are working on that also. Why can't we have blockchain technology on centralized cloud? Why can't we, kind of thing and all? And probably they'll do it, but I think the computation level required for constructing the cloud, Amazon cloud. Let me consider the Amazon cloud. I think possibly it will be double when it comes to your, when it comes to your what is that blockchain? I guess, okay, same kind of. If you would have taken the same scale, same number of users, same number of resources. I think it's completely doubled, I guess.
Okay, sir. Thank you so much. And one last question.
Yes.
Shubham Agrawal asks, how can one apply blockchain in a distributed environment efficiently?
Okay. Efficiently. Yeah. Fine. The thing is, first of all, the blockchain itself is a decentralized network. Okay, blockchain itself is a decentralized network. We don't have any kind of centralized node or centralized network to access the data or to retrieve the data or to do any kind of transaction. Only what the thing is, we can have the blockchain environment. We have incorporating the blockchain environment on the application where the centralized network they're using. Okay, so efficiently how we can use it, that depends upon the language what you'll use, the tool what you're going to use. Okay, and the resources what you're going to use, that is the way how efficient the resource and smart enough you're going to do on that. I think that matters a lot when you come to the point of efficiency with respect to distributed networks.
Okay, sir. Uh, Fine, then we'll conclude the session. And I would like to thank you so much for giving us your time. And it was a great learning experience. And all of us had these doubts regarding blockchain, and so many of us were blank about it. And you answered them so well. So thank you so much for that.
Yes, thank you so much. Before winding up this, I want to thank the chair of this chapter, Mr. Darshil, and each and everyone who worked for this, for a wonderful gesture towards me. It was a nice gesture for having you on this occasion. And as a part of ACM DSP and as a part of a student chapter of NIT, I wholeheartedly thank each and everyone for this. Thank you so much.
Thank you, sir.
I can I leave?
Yes, sir. Yes, sir.